want to just quick review and look at what it is we're building towards so you can keep a good visualization of kind of where this is headed. Our goal is to get this round ball, which we don't have any circles yet, we're going to get there, to draw this net, have some text on the screen for keeping score, as well as having the player paddle move with the mouse. We have a player paddle now drawn, but it's not moving yet. And then we also want to have this other paddle move by itself to the other side. Of course, if I miss the ball, it resets to the center. And if I block the ball, then it knocks it back. And in fact, it's not just knocking it back. It's not just reflecting. It's doing something special we'll talk about right when we get to that point. We'll continue on now. I refresh. We have this red square that'll become our ball going off the right side of the screen. And here's the rest of our code. As our program begins to grow, there's a way that we can separate out our JavaScript code from our HTML5 so it's not just packed into a single HTML file. And that's as we build up to bigger projects, we'll start to see more of that kind of technique. In the meantime, this amount of code, it's pretty manageable, pretty fine to kind of keep it all in one place. And I kind of like that it makes it easier just to save a snapshot of your project or to share it without having to worry about if all the files are in the right relative directories and that kind of stuff. We keep it simple while we can keep it simple. And as the program begins to grow in sophistication, we'll have reasons to do a little bit of refactoring, it's called, or cleanup of the code to make it easier to expand and grow. So we've got this ball, we say a ball, we have this red square, and it moves. What we'd like to do is, right now it leaves the screen, we'd like it to bounce off the edge. Now the first thing to look at is when we do move everything, we're adding 5 to it right now every frame. Remember, this is taking the value that was in ball X, adding 5 to it, and then saving it into the value of ball X. So this gets called 30 times a second, moving it forward 5 pixels every time. And the reason why it keeps moving off the screen is because this 5 can't ever change. It can only move to the right. But just like we have a variable or a var for the ball X, we can also have one for ball speed X. Let's set that to 5. I'm going to copy that. And when I scroll down here, instead of making this plus 5 every time, I'll say plus ball speed X. So remember the way the variable works is that this container, this label, which means nothing to the computer. It doesn't care about the word ball, doesn't care about the word speed, doesn't care about the coordinate, the name X. But this label to the computer, this name, refers to a number which we set as 5. And what's great about this is that now we have a variable connected to our ball speed. We can change that variable to change the ball's speed. If we make that number less during the program, it'll slow down. If we make it increase during the program, it'll accelerate. In fact, let's show you how that would look, right? So right now, as is, if I just save this, Control S, and then I'm going to bump back out to view our game. When I refresh, it looks exactly like it did before. But what if each frame, in addition to moving the ball to the right, I increased the ball speed? Equals ball speed plus 1. So now every frame, it'll increase by 1 the speed at which it's moving to the right. So this should cause it to accelerate. Let's see if it does. Save it, refresh, vroom, right? Did you catch that? There it is. I guess that way on your screen probably. No, we don't want the ball to pick up speed, but we do want to have it change direction. And how can we make it change direction? Well, if we make this a negative number, it'll go backwards. Because adding a negative to something is the same thing as subtracting from it, right? But well, first of all, let's just try that. Okay, so instead of setting it to 5, and I erase this other line, we don't want to have it accelerate. What if instead of setting it to 5, I set it to -2? Save, refresh. You'll see it wanders left instead of going to the right. And I say wander because it's going slower when it's 2 instead of 5. When I increase the number back to 5, it'll go back to the right. But in what condition do we want that speed to change from going 5 pixels to the right to going 5 pixels to the left? Well, you remember when we looked at those variables along the side, counting up as the ball was progressing towards the right side of the screen, we can see that. And what that means is that if the ball's coordinate exceeds the width of the canvas, remember this is 800 pixels wide, we define that right here in our code. The size of the window, or the canvas rather, the black playable area is 800 pixels. So if the ball's horizontal position, ball X, exceeds that width, then let's have it flip directions. All right, let's go inside and move everything. Let's add that logic. So if ball X is greater than, we know what the number is 800. We'll show in a second, we don't have to hard code it. Then, and that's how this works, is an if statement, does a comparison, if this turns out to be true, and we could do greater than, we could do less than, we could do greater than or equal to, less than or equal to, not equal to, is exactly equal to, two equal signs there, works different than a single, which is assignment, but we don't have to deal with that right now. If ball x is greater than 800, so if on this update cycle, the ball has now moved past the right side of the screen, let's tell the ball speed to go backwards. Now, there's a few different ways we can do this, right? We could say equals -5. That will tell it that when it touches the right, change the value, saved into this label, so the next time, 30 times a second, it gets to this part of the code, it'll add -5 instead of +5, and it will work its way left. And let's just show that that works. I'm going to zoom back out, refresh. There goes the red ball that way. When it hits that wall, returns it. Now, a problem with this is that when I hard code this number in here like that, what if I increase the ball's speed? Let's say we have something in our game code, as we might later, that the game speeds up as we play it. So just to experiment, what if the ball's going 15 pixels per update to the right, and it touches that other wall? It'd be quicker to test at least. Goes over there real fast, and then it goes back slowly. Because of course, by setting this number to -5, it's forgetting the speed it was going. What if instead we set it to negative itself? So if it was going 15, it'll reverse at 15. If it was going 5, it'll reverse at 5. You'll see that all I did here is instead of setting this to a hard-coded number, meaning a number that is typed directly into code, I can now have it maintain its speed, no matter how fast it was or wasn't going. If I make this 10 as the ball's initial speed, zoom back out, refresh, it'll go over there at one speed, bop off the wall, come back at the exact same speed, which is closer to probably what we want. Now, the other thing you talk about hard coding is we have this 800 here. And that's not good, because if we want to change the size of our window later, if we want to make our game 1,000 pixels wide instead of 800 or whatever else, then ideally we want to avoid typing in numbers that are already somewhere else in the code. So what we can do, I showed this a little bit earlier when we were drawing different shape positions. We can actually say canvas.width. And that works because we have this canvas variable that we set up earlier, that one right here, which we then prepared inside the window all node function by grabbing the HTML element game canvas, which we defined up here that that's the label for the 800 by 600 canvas we're drawing. Speaking of 800 by 600, that is the width and the height variables that we can get our information from because we have this handle to it. So that when I say canvas.width here in this comparison, the computer knows that what I'm really getting at is I want the width parameter of that canvas element that we grabbed earlier, which is 800. And what's nice about this is that if I later change that window, it will automatically be reflected in it. And moreover, it's just easier to read this code, right? When I look at that statement, I can understand that, okay, if my ball goes past the edge of the screen, past the whole width distance from the left side, then flip its direction. That makes more sense than 800 and thinking like, is 800 where the other paddle is? Is 800 somewhere like away from the edge? Is it past the edge? What is that number? This makes it really explicit. We'll have the exact same functionality where it bounces off the side, but it's a little more versatile now. It only bounces off one side though, it's getting bouncing off the other. And if the right side is canvas width, what's the left side? Remember that the ball's x value, when we draw that rectangle, is a distance from the left. So we want to know if it goes less than 0. Because 0 being the left side, if it goes less than that, then it is negative pixels from the left, meaning it's off the screen. And we should now have this ball bounce back and forth indefinitely. Pretty steady, pretty handy. Now notice too that right here, I still kept the same ball speed x equals negative ball speed x. Right? Don't we want to flip it to positive? And the thing to remember about what we're doing here is when we put a negative in front of something, we're really multiplying -1 times it. So if it was already -5 and we stick the -5 in front of it, then it's become positive. The way to look at this is that, okay, we have a negative and then we have ball speed x. And what I'm typing over here isn't, of course, like, don't type this. This isn't program code. This is just showing what the numbers are doing. Instead here we had ball speed x And if ball speed x was 5, as it was earlier, it becomes -5. But if it was already -5, then we're now taking the negative of the negative, which is turning it into the positive, which is what we want. So all this is really accomplishing, no matter what direction it was going, is flipping the horizontal direction of that shot. Let's also separate out this draw code, because right now it's already kind of a headache. And what'll be nice is, what if instead of having to have 2 lines for every time we draw a shape, we have a single one that we can call to draw the rectangle. And so the way we're going to do it is we're going to make a function that accepts some parameters. So here's what I mean by that. Function, color rect for color rectangle. And here I will say left x, top y, width, height, and draw color. You can call it anything, but that'll do. And what I want to do is I'm going to copy those lines from draw everything. I'm going to replace the word black here with the draw color parameter. That's the 5th one I put here. I'm going to pass in this left x, top y, width, and height values into fill rect. And what this kind of thing does for us is it gives us a template where anywhere I call color rect, oops, got this parenthesis down here, I don't need that. Sorry about that. There's the function we just defined right there. I give it the same, remember the first 2 coordinates were already left and top, x and y, followed by the width and height of the rectangle. Except now our version accepts a 5th argument, which will be the color of it, black. And this allows us to compress each of these functions into a single line. It'll work easier to replace the rect. But you see how it's taking the exact same sequence of numbers, 1, 2, 3, 4, and 5, mapping those onto these labels, 1, 2, 3, 4, and 5, for color rect, and then basically just filling those in. It's taking that value, filling it in down here. And otherwise, we can replace the rectangle functions with those. This compresses down the code for our draw considerably. Now, there's no performance benefit to doing this. In fact, it's a very, very infinitesimally, slightly more computationally expensive to do this, but like trivial. Don't worry about that amount. But this will do the same thing our program already did, but this gives it 1 line per shape being drawn. Let's go and save it and test it. No new errors, same behavior we already had. And let's also go ahead and label these. By label them, I mean, let's just at least put some comments by them. Comments are where we can put slashes in a code and be like, next line blanks out the screen with black. And anything after a slash on the same line will be ignored by the computer. It's still visible if someone has a view source on their page, so don't say anything too rotten in there. This is left player paddle. I'm just describing on each line, next line draws the ball. And I put some spacing in there. And this is a good way to leave notes to yourself. So if you come back to the code later and you're trying to remember, like, why was I drawing a white rectangle there? Which one was that? What is this for? You can annotate your code in this way for either other programmers or just for yourself in the future after you forget. And those have no impact on what the game does.